Good time of the day, boys. I'm in this abandoned building, and there are those girls like running around. It's just so low inhib, Kazakh low inhib, like right. This abandoned. It's like it's just like one floor, and there are like these girls on the rooftop, on this like rooftop inside that part of the building. Low inhib as fuck, dude. Like running the weather today is just delightful, and made me want to do a video on organic chemistry, right? Where should I sit? Right. It's kind of, the weather's kind of weird recently. Let me see. I'll sit here. Right. Okay. It's too open. Look. It's too open. I'm too low in hip, or too high in hip to sit here. And the girls are there. They're going to shout at me in Kazakh. I don't like that. I'll just sit here. Look, so organic chemistry is about compounds, chemicals that like have a carbon atom in there that is of fourth valency, so it binds 4 times, 4 of its electrons to something. So, for example, the most basic example is an alkene called. Let me put a rock in here. An alkene called methane. Methane, right? Its formula CH4. But like it's structural for like all of this, it takes all of those like electrons of the hydrogen, so it's fourth valency, right? Four minus, and each of them is plus, like, right? So it's a structural molecule. It looks like it's a fighter. I think that's what it's called. Right? So like, yeah, that's like, it's really funny. All of the chemical compounds that have a carbon atom, which is of fourth valency, but CO2 and carbonates are organic compounds. Those are inorganic. Everything else with a carbon that has fourth valency is organic. So organic compounds, they're mainly divided into 3 by the bonds they have in organic, right? Alkenes and alkynes. See, right? So, how do they differ? Right? This fucking rock. So, alkanes, they only have singular bonds. For example, let's take ethane. You see? Ethane. Because it's an alkane. See? Yes. 2 like carbon boys that are bond to each other once. And everything else, all of the other atoms, they're taken up by hydrogen, right? Or electrons. See? So its formula is C2. Right, so someone called me, my video just turned off. Alkanes, they have a formula of, see, carbon, hydrogen. Carbon is, if a carbon is X amount of carbon atoms in the molecule, then H is 2X plus 2. So C2 H6. So 2 times 2 plus 6 is plus 2 is 6. So like if we have X is 2, 2X plus 2 equals Y. 2 times 2 plus 2 equals 6. Y equals 6. See? Right. So then there is C3H8 is propane, C4H10 is butane, etc., etc. So the naming goes 1 carbon atom, 2, 3, 4, 5, 6, 7, 8, 9. So it's meth. There's no methane, by the way, because there's only 1 carbon atom, and it doesn't. There's no between carbon atom bonds, so it can't have a double bond because it doesn't have between carbon bonds at all. So F for 2, prop for 3, but for 4, pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and so on, so on, so on, so on, so on. Alright. So as for the alkanes, they're usually they're non-reactive. They don't do anything. They're basic as molecules. They're cool. They're cool. So the kids in the abandoned building became too obnoxious, and I moved. Then I was filming for 15 minutes and actually deleted the footage. So I'll just explain it again. So there's this organization. It's called IUPAC, right? IUPAC. It gives names to organic compounds. It just structures the names. So for example, this is a molecule of butane. Ignore the bottom part, right? It has 4 carbon atoms, so CH3, CH2, CH2, CH3, right? This will be called butane. If we add an ethyl group to it, so C2H5 down here, see, C2, CH2, CH3. If we add them on, it's C2H5. The group, right? It's written down here. If we add it on any kind of atom of those, it would become ethyl butane. This one in particular, you can only have 2 ethyl butane, because if we were to put it on the first one, it will become hexane. Hexane, because it's gonna just be an L-shaped hexane, right? So this is the first. We try to make the number, this number behind the ethyl group, which we call it, the lowest possible. So so we start from like the closest stuff. So this would be like, this is the closest one we can like get to be the first one instead of this one. So if we were like to take this one as first, so it would be 1, 2, 3. We would call it 3 ethyl butane, but we want to lower the number as best as we can. So we put like this as the first, this is the second, so it would become 2 ethyl butane. 2 ethyl butane, because on the second carbon atom it has a stem of an ethyl group, and it's a butane, right? Okay. I'm not gonna. It's too hard to explain these scales. This is propane, right? It has an ethyl group coming out on top and on the bottom. This would be called 2,2-dimethyl propane, because it has 2 methyl groups coming out of the second atom, and on the chain it's on like the second atom. So it would be called 2,2-dimethyl propane. There are also alkanes. Right, I forgot to mention alkanes. They were called paraffins before because they were so non-reactive, because they were like inert, right? They're non-reactive because the carbon bond, this bond, is very strong, and the bond between the carbon and the hydrogen is as well. So alkenes are the guys that have a double bond. Any amount of double bond, just one makes them alkene. This one in question, I just circled the bond. You don't circle it usually. This is ethene. It has, so 2 of the carbons, they weigh 2 on the double bond and 2 on the hydrogen, so it's 4 in total. It's organic, right? This is an ethene, right? And fuck this one. This is ethene because it's it's 2-ene because it has double bond. So if we come to naming, right? Forget this one, right? We forget this one. So this is a propane atom, right? It has 1 double bond between its carbon atoms. it's the first bond in the count. So C C C. This we'll take this as first because we don't want to like take it this because the number of the bond will be 2. We want the lowest number. That will be called propene 2 or propene 1 because it's on the first bond is a double bond. So get the one on. So let's see like propene 1. I just just put a line over it because I made a new molecule to show you that if we like, for example, we take butane, right? And we give it double bonds on its, they make the first and the third bonds double. It would be called bufadiene 1 free because it has 2, so it's diene, bufadiene, D 2 because it has 2 double bonds, right? Those are reactive enough to under certain like harsh conditions to even make like polymers. So this is polyethylene. So ethene is sometimes called ethylene. This is polyethylene. Poly as in multiple, ethylene as in ethene. So the double bond can break down, and those two guys have a carbon atom that doesn't do shit, or has have an electron from the carbon that doesn't do shit. So it just puts it in the outside, and they like chain together very long, and it makes like a huge molecule of a shit ton of ethanes. Just like ethanes. Previously known as ethanes, now it's a singular bond because this bond broke down. It like put the hands on the outside, and this is like polyethylene. It became polyethylene because there's multiple ethylenes in one. So this is the repeating unit. So H2C singular bond, CH2, and 1 bond from each side. N is the polymerization rate, so how many repeating units you have. And like low density polyethylene is used in plastic bags, high density is in bottles. So, right. So alkynes, those have a triple bond. So this is affine. We won't cover those. Those are too hard for now. They're funny. They're very strong because the triple bond is really hard to break down. It has like... Alright, I forgot to mention the reason why ephenes, why alkenes are easier to more reactive than alkanes, because the double bond, one of those double, this one, like see those two bonds, one of those is a sigma bond. It's called a sigma bond. It's strong. The second one is called a p bond. So if you have a double bond, one of them is a sigma, the other one is a p, and the p bonds are much easier to break. That's why they're more reactive. Okay. So organic compounds can have functional groups. For example, one of them is the hydroxyl group. The hydroxyl group, like that's what it looks like one thingy. O reacts with H, right? This is OH, hydroxyl. Hydrogen, O oxide, right? The organic compounds with a hydroxyl group are called alcohols, right? For example, imagine, okay, right? Ignores the O in here. This would be ethanol because it has 2 carbon atoms and has 1 OH group here, right? This is ethanol. Ignore the diol because I just made an example by adding an O group, right? An oxide. Ethanol is the alcohol that's used in alcoholic beverages that makes you drunk. This is its formula: C2H5OH. In normal alcohols that have 1 hydroxyl group, their like structural formula is CXH2X plus 1 OH. 2x plus 1 because one of the things taken away by OH group, right? So this would be called ethandiol because it has 2. Now that we like don't imagine that there isn't an oxygen, this would be called ethandiol, otherwise known as ethane glycol, right? It's a funny guy. Now those guys, the alcohols, they're pretty funny. Ethanol could be used as biological fuel, etc., etc. They burn pretty well. When they burn, they just make water and CO2, right? So there's the carboxylic group, COOH. So it's basically, it looks like this, right? It has carbon atom and out of it is stemming one oxygen with a double bond between them. This is a strong bond; it doesn't react, and a hydroxyl group on the lower side. So the hydrogen atom in the hydroxyl group from the carboxylic group is the most reactive one. So for example, if wait, that's we'll cover that later. So the carbon in the carboxyl group is also count. So if we have this, we have 1, 2, 3 atoms. This will be prop, and this would be an acid, right? Carboxylic group makes them acid, so there would be propanoic acid, right? Prop because free oic acid because it has a hydroxyl group. So an acids reacts with metals. Look, this would be the methanoic acid. It's usually called the formate. It has just one carbon atom, so that's why it's meth. See, ACOH is the shortened. We add sodium, it becomes ACO sodium with the emission of hydrogen. It's because it's like put in the hydrogen place, right? And this is called sodium formiate. And this is like funny, right? And when the hydroxyl no the alcohols react with carboxylic acids, they make ethers. Ethers are used everywhere in your drinks, in your steroids, like funny stuff, right? For example, we take butanoic acid, right? So 1, 2, 3, 4, and on the first one stems, right? And we add the spirits of methanol, right? So it has right one hydroxyl, one carbon atom, 3 hydrogens. They're gonna react together, and the hydrogen from the hydroxyl group on the alcohol, not the OH group, from just the hydrogen, and the entire hydroxyl part of the carboxylic group on the butanoic acids, they're gonna combine together as water and condensate, and this O that's left is gonna connect with this this O that's left here is gonna connect with this carbon atom, and it's gonna make an ether. Look, an ether. So this is the one that was CH3OH, CH3OH, the one that was like the methanol. This part is the one which was the butanoic acid. This would be called methyl butanoate. So the methyl name, the beginning of the ether name stems from the part that was that was the alcohol, and this name, it's the end of the name. So butanoate is the one that was the acid. So methyl because the methyl, butanoate because it's butanoic acid, right? So those that reacts with the carboxylic group of the no, not the carboxylic group. Those that react with the methanoic acid, those are called formides. So that one sodium which we made react with the thing would be called sodium formide. And when you react like some kind of metal or compound or other organic compound to etherize it with the ethanoic acid, I guess it's called an acetate. This is called the acetic acid. Like that's the trivial name, right? So for example, trenbolone acetate, it's gonna have, see this, the CO, like the carboxyl group, but it has no hydrogen, and there's your tren here, for example, right? And there's the like 2 carbon atoms. It's gonna be tren acetate, right? So 2 organic compounds that are both part of the same group, like for example propane and butane. Those 2 guys, they have different formulas, but they're both basic alkanes, so they would be homologous, right? And isomers would be the guys that have different carbon chains. For example, see, you're gonna have butane, right? It's gonna have 4 carbon atoms, and it's gonna have, yeah, this practically fully normal, and you're gonna have, if you're gonna take one of the methyl groups on the side of it and put it on the second atom of the propane we got from removing the methyl group, we put it there to the second atom, we're gonna get 2-methylpropane. 2-methylpropane would be also known as isobutane. So it's gonna be an isomer of butane by its carbon skeleton. I'm gonna show the pictures in here, right? Yeah, you're gonna have isomers. You're gonna have homologous stuff. That's basic organic chemistry in X many minutes. I don't know what X is. Thank you for watching. For faggots who watched till the end, thank you, I love you. And I'm going home, tomorrow's my birthday. I'll probably pull the shift tomorrow. And thank you, good luck.